So the demo we're going to show is a line bike service where if you haven't seen them before, basically the bike's out on the street where you can go out with your phone, unlock it, take it for a ride, and then when you're done, you pay for it, right? So it's kind of an example of a service that we can build with Eventual. So we'll let that progress. And the first step in Eventual is you always just write your requirements. This is what you have to do as a team. And by writing requirements, we really mean just writing a document, right? So here we're describing the users in the system, the different actions that they can take, and we're just using natural language to describe what each of these actions should do and how they're implemented. We also do the same for queries, which is how we read data, and also workflows, which are your operational processes. For example, at the end of a ride, process the payment, lock the bike, and send a notification, right? So a very simple way of describing a complex operational process. And then you put that document into our eventualAi smart agents who then design the system. So we'll just show one example here of the finalized ride system. So this is AI taking that requirements doc and breaking it down into a detailed technical design. So we've got the input properties, their data types, the output properties, their data types, and then as well as like a detailed list of the steps that workflow should perform. And you can see it elaborates on what we originally provided. So it's going into the success cases and the failure cases, gets into some low-level detail. So that's work that typically an engineer would have to do. And it also goes through and does the approval step of reviewing its work, right? So here you can see it's saying, hey, this is not really meeting our standards, you're missing this property or the data type's wrong, etc. So it really just iterates until it reaches a high level of consistency and quality. And it does that in parallel for all the different components in the infrastructure. So it's doing a low-level technical design in massive parallelism. The next step is we take those low-level designs, which were produced by AI, and we put that into our code generator, which also uses AI to generate the code that implements those requirements. So take a quick look at that. So you can see here, it's just going to spit out a bunch of codes. You can see them all running in parallel. We got the entities, the events, they're all being implemented. And that's AI taking the requirements, understanding them, and translating that into a solution in TypeScript. And we'll just let all those different queries, tasks, commands, events, and then we'll take a quick look at what they look like. So here's the Prisma schema. So it designed this relational database schema for how to store your data. So we've got the bike and their properties, relationships between these different models. So that's all designed just from that document that we put in at the beginning. Then writes code using the eventual framework. So this is data backed by DynamoDB. We've got all the properties in a well-structured form. This is high-quality code that you'd expect a senior engineer or mid-level engineer to implement, all done automatically. So here are the events for whenever an account is created, we're going to publish an event with those properties. Do the same for all the queries. So this is actually how we're going to read data. So using this command primitive from Eventual, which takes care of all the infrastructure complexity, and it just writes the code and takes advantage of TypeScript to make sure it's all correct. And then same for our transactions. So putting data into the system. Here we're putting a bike into the database and emitting an event that the bike was added. And finally, really complex part is the workflow, which is orchestrating what happens at the end of the ride. We're going to process the payment, lock the bike, and send notification. And I say it that way on purpose because it's meant to sound exactly like the way we wrote it in the requirements. Remember I said process the payment, lock the bike, and send notification. You can see that translating directly to code here, except the AI is taking care of a lot of details that an engineer would typically have to do. So it also figured out that it needs to handle errors in an intelligent way. So useful stuff that the AI can perform. And then finally, taking advantage of our framework, we can deploy that directly to AWS with a best practice serverless architecture. So this last piece here will just show generating all the IAM policies and the configuration and the Lambda functions and the tables and all that interesting infrastructure. All that's taken care of for you. So we'll see that just get created. It's bundling all our code, and then you can see here it's creating IAM roles, SQS queues, buckets. So we've abstracted over that complexity and provided a way to generate that rather than having to worry about that as people. So you'll just see that service deploy. It's deploying 81 resources here. And that'll be the end of the demo. That's basically how you can go from a requirements document to a low-level design to implementation and to an actually fully functioning deployed service on AWS using AI and natural language.